In this practice, distance between carbon and oxygen nuclei is 0.1128 nanometers for CO molecules, carbon monoxide. The masses of the carbon and oxygen atoms are 1.993 times 10 to minus 26 kilograms and 2.656 times 10 to minus 26 kilograms. The first question is to calculate the rotational energies of the first excited state. First question. So energy is expressed, rotational energy L squares over 2I. L is the angular momentum. I is the moment of inertia. So L is L squares. L is going to be L times L plus 1 h bar squares. So from this equations, you can find that the first excited state is L equal 1. You need to substitute L equal 1. So L squares is obtained just 2 h bar squares. Okay, and the I is a moment of inertia. We consider the molecules is m sub 1 and m sub 2, and distance between the two atoms is r sub 0. The moment of inertia expressed mu times r sub 0 squares, and the mu is a reduced mass. Mu is a reduced mass. Is m sub 1, m sub 2 over m sub 1 plus m sub 2. This is the moment of inertia. Then we could calculate the moment of inertia for the CO molecules. So mass of the carbon, mass of the oxygen atoms over sum of the two masses times r sub 0 squares. So r sub 0 is 0.1128 nanometers. Then if you substitute all the values, you can find the moment of inertia is 1.449 times 10 to minus 46 kilogram meter squares. Then you can substitute this L squares and I. Then energies can be calculated. I just show you the answers. 7.676 times 10 to minus 23 joule. Or if you express the energy in the electron volt, 4.79 times 10 to minus 4 electron volt. So this is the answer to the first questions. And the second question is to calculate the wavelengths of photons emitted in the transitions from L equal 1 to the L equal 0. So this means energy is given by this. This is the energies we can use. So energy is equal to the HF. So from this equation, you can find F equal E over H. But question is, we need to find the lambdas, the emitted wavelengths of our photons. So lambda is C over F. Then you can substitute this F. It's going to be HC over E. So for the E, you can substitute this E. Then H is Planck constant. C is the speed of light. Then I just show you the answers. 2.59 millimeters. This is the wavelength of emitted photons. This is the answer to these questions.